Well, this video is for Math 60 for the assignment on algebraic substitution. And so this takes the concepts that we had just talked about in terms of order of operation and working with positives and negatives, and it connects it with the algebra that we're headed towards in the course. Okay? So this has a lot to do with formulas. Formulas are used in a lot of different places. I mean, they're used in the sciences extensively, but they're also, of course, used in business and a lot of other situations as well. Okay, and this really gets at the heart of algebra, which there was a professor at University of California who's retired now. He used to write a lot about math and teaching math. And he talked about how algebra is doing arithmetic with letters or variables, okay? And so that's what we're going to be talking about in terms of algebra. And this is where we're going to start, okay? So first off, let's look at some problems here. In the first set of problems, we've got these standard values. A equals -3, B equals +2, and C equals -4. And we're being asked to make some calculations. In problem 2, ABC plus B squared. Okay, now when you see the letters written like this, that means A times B times C. Okay, so I'll use parentheses when I plug the numerical values in for each of these variables, okay? We know that A is equal to -3, so let's put a -3 in there. B is +2, and C is -4. And then the B squared is just going to be 2 squared. Okay, now, we have calculators. I encourage you to use them. It's a lot faster for me to do this without calculators, unless I come up with something where it'll be faster to reach over and grab the calculator. Okay? So this will be +12 times 2, so that'll be +24. And this is +4 over here, and so we should get 28 for this. All right, so that's the basic idea. So we're going to have this formula that's written out in terms of variables or letters, and then we're going to take the numerical values for those and plug them in to calculate a numerical value for that expression. All right, problem 4, 2 times B minus A minus C. Okay, so I'm going to do the same thing I did in problem 2. I'm just going to put the values for each of these variables in here. B is equal to 2. And A is -3. Now, I want to stop for a second and point something out about this. Notice this minus sign was part of the original formula. But the variable A contains a negative sign as part of its value. Okay? So you've got this negative sign that's part of the formula, and then you've got the negative sign that comes from the value of A. And the same thing is going to happen over here. With C, we're going to have minus -4. So this minus sign comes from the formula. This minus sign comes from the value of C. And that's something that people often forget to include. And so in both of those cases, this is going to be 2 plus 3, and that'll be plus 4. So this is 2 times 5 plus 4, 10 and 4 make 14. All right. Let's see here. Well, let's do problem 6. A squared plus B squared plus C. And again, I'll start out by plugging in the values for each of these variables. Okay. Now notice that I wrote this -3 in parentheses squared. And I think we talked about this when we were talking about multiplying or squaring negative numbers, right? If you type this into your calculator will tell you that's -9. But -3 squared is negative 3 times negative 3. That's positive 9. Okay? This thing right here, negative 3 squared, that means negative 3 times 3. And that all has to do with the order of operations. Okay? The order of operations says this has to get squared first and then apply the negative to it afterwards. This says it's the negative 3 itself that is getting multiplied by itself. So that's another trap that I encourage you, please, not to fall into. Okay, so negative 3 squared is 9, 2 squared is 4, and then we get plus negative 4, which just means minus 4. This makes 0, and so in the end, we just come out with 9. Okay, let's keep going here. Now in the next section on page 1, now we've got different values and different variables. We've got x, y, and z. In this case, x is negative 3, y is 7, and z is negative 6. Okay. Let's see here. Oh, problem 8. 3y minus z. So again, let's put the value of these variables in there. So that'll be 3 times 7 minus negative 6. And again, notice that this minus sign comes from the formula, but this minus sign comes from the value of z. So this will be 21 plus 6, and that'll make 27. Okay. Problem 10 looks kind of similar, but is different. Okay, you can see this is 3 times y minus z. This is 3 times parentheses y minus z. All right, so let's see here. The y is 7, the z is negative 6. Now, the difference between these is that the order of operations says work in the parentheses first. So that'll be 7 plus 6, and that'll be 3 times 13, which makes 39. Whereas over here, we did the 3 times 7 first, and then added the 6 to it. Okay, and you'll see these problems in this section do that frequently. You'll see things that look similar, but actually give you different answers. Okay. Let's see here. Yeah, let's look at problem 14. 14 is 5x to the third power. X is negative 3. And we want to raise that to the third power. Okay, so the order of operations says do that exponent first. So we need to do negative 3 to the third power, and that should be negative 27. And again, you can do this on a calculator. In the end, it's just negative 3 times negative 3 times negative 3, which is not all that challenging. Let's see here. 5 times negative 27, so that should be negative 135. Okay. Now, problem 16, like I was just saying a minute ago, looks similar, but is different. This is 5x inside the parentheses, and then it gets cubed. Here, notice that the 5 doesn't get cubed, but in this one, it will. I mean, it'll be multiplied by the x, and then it'll get cubed. Let's see. So the x, again, is negative 3. So that'll be negative 15 to the third power. And this is a good one for the calculator. So we go... so again, with the calculator, you can do this. Okay. You can do this. Doesn't matter. It's the same thing. Negative 15 times negative 15 times negative 15. And so this will be negative 3375. And again, notice that these are two different answers. All right? And the key here is the order that we perform these operations in. Okay, let's do one more pair of these. Let's see here. Yeah, so problem 18, we get x plus z squared. So let's see here. X is negative 3 plus z is negative 6. So you've got a double sign here. That's just going to be negative 3 minus 6. Negative 9 squared, positive 81. All right, problem 20, x squared plus z squared. So the x again is negative 3, the z negative 6. So this one's 9, this one's 36, and together they make 45. Notice that these are different, and that's important. This is one of the most common mistakes in algebra that people make, is that they think that x plus z squared should be x squared plus z squared. But you can see that they're not the same. Okay? What happens with this one, here I'll take a minute to write it out. Squared means to multiply it by itself. So this is something that you this is something that you do in Math 7. Okay? We'll do something that leads up to this, I believe, but in Math 70 you'll get into it in more detail. And the idea here is you have to distribute. There's the x squared, but then you also get an xz. And same thing here. There's another xz, and then there's a z squared. So this is x squared plus 2xz plus z squared. Right, so if we want to make these two equal to each other, like if we took this 45 and we added on 2xz, which is 2 times negative 3 times negative 6, I'm getting there, 45, let's see, that's 18 times 2 is 36, and there's your 81, okay? So this and this are the same. All right, for this region. But like I said, you don't need to worry about this. This is from Math 70. Okay? But one thing I want to make clear is that this and this are different. Okay, let's look at some problems on the second page here. Now in these problems, we've been keeping the values of the variables the same, but changing the formulas. On the second page there, we've got the same formula each time, but different values for the variables, at least in each pair of odd and even problems. So in problem 24, P equals 4s, so that's the perimeter of a square. If s is 0.8, then that'll be 4 times 0.8, which is 3.2. Okay, 26. P equals 2L plus 2W. So that's the perimeter of a rectangle. And what do we have here? L is 12, W is 2. So that'll be 2 times 12 and 2 times 2. And so that's 28. Okay. Problem 28, area equals pi r squared. That's the area of a circle. And we've got pi approximated to 3.14. And in this problem, the radius r is equal to 3. So this will be 3.14 times 3 squared. And how you go about calculating this is up to you. You can calculate that as 9 first. Let's see here. So 3.14 times 9, 28.26. Okay. Now this value for pi, I think, is kind of interesting. It's one of those things that's always presented to you in sort of a forwards direction. This is the value of pi, whereas in reality, it's actually calculated in a backwards direction. Typically, I think where people first encountered pi was the relationship between the circumference and the diameter, right? The circumference is pi times the diameter. So what is pi? Pi is this ratio. If you measure around a circular object, let's see, I'll use the trash can. These markers are too small. So if you measure around the circumference and you measure across the diameter and you divide those, you should get pi. Okay? There are better ways to calculate that, but this is an activity that a lot of elementary and middle school math teachers use, where they get the kids to get in a big circle like this and they measure around the outside of the circle and they measure across the circle. And the idea is that you should come up with something close to 3.14. It's kind of a fascinating thing, something that human beings have been working on for literally thousands of years. Okay, let's see here. Problem 30. We've got, area for a triangle. 1/2 the base times the height, where we've got a base of 5 and a height of 11. So that's 1/2, 5 times 11. And you can just take that 55 and divide it by 2, and there it is, 27.5. And then the last one on here, problem 32, this says distance equals rate times time, where our rate is 180 and the time is 7. So let's say this is miles per hour and this one is 7 hours. So that means we would do 180 times 7. I think I'll get the calculator for that one. And that's 1,260 miles. And so that's something that a small airplane might travel at that speed. Right? So if you traveled at 180 miles per hour for 7 hours, you'd go a little over 1,200 miles, 1,260 miles. Okay, this is something that is actually very similar to this value for pi. It's always presented in this form, but where it really comes from, this rate, okay, comes from taking the distance traveled and dividing by how long it took you to get there. Okay? And that's where the average speed or rate comes from. Okay? Again, that's not something you really have to worry about. It's just something to think about a little bit, where these things are coming from and what they mean. Okay, so I think we'll have I think that this will be it for the algebraic substitution, and then we'll move on and talk about some more concepts from algebra. As always, if you have any questions, please let me know. Thank you.